First you write small n, and this small n is nothing but product of all the ni's, because we have ये मानेंगे नहीं CS वाला ज्वाइन करेंगे, बीच बीच में कूदता रहता है. So small ni is given, or small ai's are given. K small ai is there, k small ni is there. First, what we did, you just make a product of all ni's, and you write that product as a small n. That means this small n is nothing but n1 dot n2 dot nk. So all k's, we take a product. We write small n1 and convert small n divided by small n1, because small n1 is given, and just you find your small n, so you can get capital N1, similarly capital N2, similarly capital N3, and finally is capital Nk. And what your small xi? So small xi satisfying this congruence equation, because see that just you find capital Ni, small ni is given, so this is a one congruence equation, and solution of this equation is we denote by small xi, and this is ultimate small unique solution. We just will see that this is small unique, has a unique solution. So if you have a system of congruence equation, this k congruence equation, then this congruence equation where see that there are many conditions that GCD of Ni and Nj are 1 for each I different from j, and N1, N2, Nk are positive integers, and A1, A2 are only integers. Under these conditions, this method say that this system of linear congruence equations has a unique solution, modulo this one. यानी कि इस नंबर के अंदर जो भी सॉल्यूशन मिलेगा वो 1 मिलेगा, एग्जैक्टली यूनिक मिलेगा. So I'll try to explain this method by some short examples. So first see that I'm talking about problem 5.1.1, and here just we consider only 3 linear congruence equation. First one congruence equation is x is congruent to 2 modulo 3, data is small one, so I don't think we'll get to difficulties to understanding the data here. In next congruence equation, I write x is congruent to 3 modulo 5, and in last congruence equation is nothing but x is congruent to 2 modulo 7. I'm talking about problem 5.1.1, and here we consider 3 linear congruence equation, so that form a system. The system of 3 linear congruence equation. Here, if you use the notation from the Chinese remainder theorem, then you can consider A1 as a 2. You take this entry as A1, and this entry is N1, small n1. So small A1 is equal to 2, and small n1 is equal to 3. Small a2 is equal to 3, and small n2 is equal to 5. Small a3 is equal to 2, and small n3 is equal to 7. So just I write just by using the notation from the Chinese remainder theorem. So just I collect the data, then I find the small n, and small n, how you find small n? Small n is nothing but just you taking the product of all ni's involved in the question. So here only 3 ni's there, n1, n2, n3. So just small n. So just I write small n. Small n is here nothing but n1 dot n2 dot n3, because n1 is equal to 3, n2 is equal to 5, n3 is equal to 7. So the small n is about 3 into 5 into 7, that means 105. You can just compute. I think this answer is correct. 3 into 5, 15, into 7, 105. So answer is correct. Okay. Now, because we have computed the small n, your next step, to compute capital N1, and using the notation from the Chinese remainder theorem. So there capital N1 is nothing but small n divided by small n1. So here small n, just you computed that 105, and your small n1 is nothing but, just I collected the dot here, the small n1 is equal to 3. That means capital N1 is nothing but 105 divided by 3. And if you divide 105 by 3, we'll get 35. I think this answer is correct. So capital N1 is equal to 35. Similarly, you compute capital N2. So capital N2 is nothing but small n divided by small n2. So small n is nothing but 105, just we have computed, and small n2 is given, this is 5. So n05, 105 by 5 is nothing but 21. And also finally we compute the capital N3, and capital N3 is nothing but small n divided by small n3. So small n is equal to 105 and small n3 is equal to 7. So when you divide 105 by 7, we'll get the 15. So just you computed capital N1, capital N2, capital N3. So see the solution of small a1, capital N1, small x1, plus small a2, capital N2, small x2, plus and so on. In finally, small ak dot nk, capital Nk dot xk. Because in this problem we have only 3 equations. So in here the form of the solution will be this one: small a1 capital N1 dot x1 plus small a2 capital N2 x2 plus a3 capital N3 x3. This is only 3 terms involved in the solution. So here a1, a2, a3 is already given in the question, and we just computed the your capital N1, capital N2 and capital N3. So your last step to compute the what will be the small x1, small x2 and small xk. This is your last goal, to find your small x1, small x2 and small x3, and see small x1 must satisfy the equation capital N1x congruent to 1 modulo small n1. So just using that one, see I write that. Now your last step to compute the x1, x2 and x3 is small. So for x1 we consider this equation capital N1x congruent to 1 modulo n1, and solution of this equation we call the x1, small x1. So just you put the values of capital N1, this is nothing but 35, and small n1 is nothing but your 3. So just you put the values, so your equation will become like this one. Your equation will be look like this one: 35 congruent, 35x congruent to 1 modulo 3, and 35 in congruent modulo 3 in system, 35 is equal to the 2. I think correct? Yes. Yeah, even you can forward. So can you tell me the solution of this equation? Anyone? So what is the x that satisfies this equation?
2, sir.
2, sir.
Huh? 2.
2.
So I write the solution. That means here your x1, we denote the solution of this one, and you can also see that solution of this one is unique because GCD of an is equal to 1. GCD of n equal to 1, because you have to already discuss that the number of inequivalent solution is nothing but D. D is nothing but GCD of an. Sure. So solution of this one. Now, just me you can also see that finally, that means we have come to our last step. Now we are next step goal to find the small x2, and for small x2 we have to consider this linear congruence equation, capital N2 x congruent to 1 mod n2, small n2. And the solution of this equation we denote by small x2. So see here, capital N2, we have just computed this capital N2 is equal to 21, and your small n2 is nothing but I think 5 given in the equation, given in the problem. So just to put the values of capital N2 and small n2, then your equation will look like this one, this congruence equation. 21x is congruent to 1 modulo 5. And can you tell me the solution of this equation?
One, sir.
1, sir.
1, because if you put x equal to 1 in this equation, then 21 into 1 minus 1 is divided by 5. So that means solution of this equation is 1. Anil Gupta ji, Anil Gupta, roll number 5, are you there?
Yes. Sir.
आप अभी ज्वाइन किए हो, क्या इशू था बताओ?
सर कुछ काम था उसमें से लेट हो गया सर.
क्या हो गया था?
कुछ काम था सर घर में, इसीलिए.
तो आप तो ज्वाइन करने की क्या जरूरत था? अभी और लॉग आउट हो जाओ जल्दी से, काम करके आओ. So now that means we have computed your x2, and solution of this equation we denote by small x2. So this is your x2 I have written, and finally because x1 you have to compute it, x2 just to be computed. Now you have to find your small x2, small x3, sorry, small x3, and for small x3 you will have to consider this linear congruence equation, capital N3x is congruent to 1 modulo N3. And see here, capital N3 we have computed. Capital N3 is nothing but, you see the dot capital N3 we have computed 15, and 15, a small N3 is already given in the problem 7. So just to put the values of capital N3 and small n3, then your equation will look like this one. And can you tell me the solution of this equation?
1.
1, again 1, because if you put
1.
x equal to 1 in this equation, then 15 into 1 minus 1 is equal to 7. So solution of this equation is 1, and that's why, because we have already computed everything required for the solution, because already given small a1 values, small a2 values, small a3 values in the equation, capital N1, capital N2, capital N3 we have computed in the beginning of the solution. And finally you have to compute small x1, small x2 and small x3. Then this is the, by the method, this is the your solution of the system of 3 linear equation. This is the form, just I write, and then I put the values of all the ai's, capital Ni's and small xi's. So see, small a1 is equal to 2, already given the problem. Small a2 is 3 and 2, so just you will see that. So a2, instead of a1 you write 2, instead of capital N1 this is 35, you have to compute it here, and small x1 you have to compute it somewhere this one. So just to put these values, then small a2, this is given in the problem 3, and capital N2 we have to compute it 21, and x2 we have to compute it, this is 1, then plus a3 is given in the problem 2, capital N3 we have computed 15, and x3 we have just computed. Sorry, this is x3, this one. So just you put the values of this one. So just then you computed this. The first component is 140 because 2 into 2 4 times 35 is equal to 140 plus 63 3 into 21 63 and 2 into 15 is 30. Then you sum up this one 233 and 233. This is the solution, no doubt, but in the congruent modulus 105 is nothing but small n. This is the product of n1 n2 n3. In your solution will be 23 because 233 in 105 system is nothing but 23, because just to divide 233 by 105 we get the remainder 23. So 233 in the model 105 system is nothing but 23. That means 23 is the solution of this given system of three linear congruents. And see that if you put 23 in this system, see that every equation must be satisfied if you put the x equal to 23 in each equation. Just to put the values of x equal to 23 in each equation, we'll see that the equation is satisfied. In first, you put x equal to 23, so 23 minus 2 is equal to 21, and 21 is must be divided by 3. You know that. In second one, if x equal to 23, so 23 minus 3 is equal to 20, and 20 is divided by 5. In third one, x, if you put 23, then 23 minus 2 is equal to 21, 21 is divided by 7. So 23 is a solution. Is not only solution, this is the smallest positive solution for this equation. That means there is no positive solution which is less than 23 of these three equation. यानी ऐसा कोई x मिलेगा नहीं 23 से छोटा जो इसका solution हो सकता है. आप कोई वैल्यू रख दो नहीं मिलने वाला. यानी 105 सिस्टम यानी 1 से लेकर 105 के बीच में एक ही सॉल्यूशन मिलेगा 23 जो इस तीनों का सॉल्यूशन होने वाला simultaneously. So that is a strong method to know the solution if we have a system of linear congruences. So if you have any doubt, you can stop me in between, and you can again ask at any step you have any doubt then. Otherwise, I'll move to the another problem. And here again questions say that find the smallest positive integer solution of the following system of linear congruence equation. So here we have given three linear congruence equations. First one is x is equal to 2 modulo 5. Another next one is x is congruent to 5 modulo 8. And last is x is congruent to 4 modulo 37. So in other language, you can say same question, find या write a positive integer that gives remainder 2 when divided by 5, gives remainder 5 when divided by 8, and gives remainder 4 when divided by 37. It's the same question to find the remainder when divided by the integer 5, 8, and 37. So see, this is a question, and this question will handle with the method we have just discussed, Chinese remainder theorem. And just to maintain the notation, so here we call a1 as a2, a2 is equal to 5, and a3 is equal to 4. Small, I'm talking about small a1 is equal to 2, small a2 is equal to 5, and small a3 is equal to 4. Just I record these values because I'm going to use the method known as Chinese remainder theorem. And we also call small n1 as a 5, small n2 is equal to 8, and small n3 is equal to 37. So you just recorded this value. This is given in the equation. This is a question. Now, because our next goal to find the product of all these ni's given in the equations in the question. So here only n1, n2, n3 is given. So just to take the product of n1, n2 and n3 and write this values as a small n. So small n1 is equal to 5, small n2 is equal to 8 and small n3 is equal to 37. So just to take the product, I computed the values of this product is 1480. You can cross verify this value. Just I computed in the morning. This value I got 1480. I think that should be correct. After that, getting the values of small n, our next goal is to find capital N1, capital N2 and capital N3. And capital N1 is equal to small n divided by small n1. And I got the values 296 because small n is equal to 1480 and small n1 is equal to 5. So just divide 1480 by small n1, I got 296. In next, I got capital N2. This is nothing but small n divided by small n2. And this value is 185 because small n is equal to 1480 and small n2 is equal to 8 only. So I got 185. In next, I calculate capital N3. This is nothing but small n divided by small n3. I got the values of capital N3 is equal to 40. Now, so if you want to write a solution of a system of linear congruence equation, then we need values of all the small ai's, the values of all small capital Ni's, and finally values of all the small xi's coming from the solution of the equation capital Nix congruent to 1 modu small ni. So if you find the values of x1 one by one, I'll go to compute the values of small x1, small x2 and small x3. First I'm going to compute the values of small x1, and for that I consider this equation capital N1 x congruent to 1 modu n1, and capital N1 is given. Just you computed the values of capital N1. This is 296 and small n1 is 5. Just I put the values of capital N1 and small n1. Then I got this congruence equation. And anyone, can you tell the solution of this equation?
One.
Sir, one.
1. You can easily see that because just put the x equal to 1. So 296 into 1 equal to 296 minus 1 divided by 5. Otherwise, what I did is simply because 296 is a big data. So what I did, I just consider 296 in the modulo 5 system, and 296 in modulo 5 system is look like a integer 1. So just I convert 296 from 296 to 1 because because we are doing everything in modulo 5 system. So if number is bigger than 5, then divided by 5, so we'll use get the small integer. So 296 is equivalent to 1 in modulo 5 system. So just I remove 296 and put the values 1 because 296 is same as 1 in modulo 5 system. So otherwise, easily we see that solution of 296 x is congruent to 1 modulo 5 is 1. Otherwise, you convert this equation in this form because 296 is same as 1. So just I put 296 equal to 1 and 1 dot x congruent to 1 modulo 5. So both equation is same because 296 is nothing but 1 in modulo 5 system. So I write same equation in different form. Both are same because 296 and 1 are both are same in modulo 5 system. So instead of 296 writing, I write the 1 instead of 296. And now we can see that 1 is the solution of this equation because now data is a smaller one. So easily you can find the solution. If data is bigger one, then what you do? You just convert all the data in modulo system. So then data will be the smaller one. Then you can easily observe the solution of that equation. So now here 1 is the solution. That means x1 is nothing but 1. And for x small x2, we have to consider this equation capital N x congruent to 1 modulo N2, and capital N2 we have computed. Capital N2 is nothing but 185 we have computed here. So just put capital N2 values 185 and the small N2 values 8 in this equation. So we got 185 x 1 modulo 8. And can you see the solution? Can you tell the solution of this equation?
One, sir.
Yes?
One, sir.
1, yes, because otherwise you can 185 is same as 1 in the modulo 8 system, because we are doing everything in modulo 8 system here. So we can write same equation in this form, 1.x is congruent to 1 modulo 8, and here you can see that 1 is a solution of the this equation. That means the x2 is 1, and finally we are going to compute the values of x3, and for x3 we have to consider this equation. Capital N3x is congruent to 1 modulo N3, small n3. And capital N3 we have computed. This is nothing but 40, I think. So capital N3 is 40, and your small n3 is 37. 37. Then just put the values of capital N3 and small n3 in this equation. Then we'll get the this equation. And can you tell me the solution of this equation? What is the value of x for this equation is must satisfy? So it is little bit difficult. That's why I did everything in the module 37 system. Then 40 can be treated as 3 in module 37 system, because 40 is same as 3 in module 37 system. So instead of 40, I write the 3 and convert this equation in this form. So instead of 40, I write 3. 3 dot x is 3x is congruent to 1 modulo 37. Now you can tell me the solution of this equation. Anyone?
Sir, 25.
How get 35?
25.
How get why claim that 35 25 is the solution?
It satisfies, sir. 3x 3.
3 into 25
How?
is 75, and 75 minus 1 is 74. That is divisible by 37.
Good, thank you. That means this is 25 is the solution of this equation. So that means x3 is 25. Just that means we computed everything required for the solution of the given system of linear equation, because all ai is given, all the capital Ni values are we have computed, and finally we have computed the values of all small xi's. So just to put the values of all these parameter in this. So this is a solution. Solution is formed. This one, x is equal to a1 capital N1 x1 plus small a2 capital N2 small x2 and so on, a3 capital N3 x3, and put the value, because just we have computed everything required for x and just put all the values. So I got, and this is the solution for the given system of equation 1077. 1077. This is a solution. So that is not easy one. That means we need, because this that means what is एक कौन सा x हो सकता है जो तीनों इक्वेशन को satisfy करे? In the Hindi, you said that what is the x, what is the values of x that satisfy all three conditions? Yeah, what is the positive integer? When that integer is divided by 5, we get the remainder 2. When we divide by 8, we get the remainder 5, and when we divide by 37, we get the remainder 4. And this number is not a smaller one, you cannot easily trace. We have to do some computation, and in this case, Chinese remainder theorem is useful, and that using this method we get the values 1077. So also I write another question problem solution of this one, but I think you solve this question. Now I asked to find a solution of this given system of three linear congruence equation. I'm talking about exercise let's try to find a solution in model N1, N2, N2, N3 system. Can you guess the x values? Anyone? Can you guess the solution of this system of linear equation? Otherwise, you have to use the that channel remainder theorem to compute the solution. I can see the solution of this equation. That's why I put this question in the first question as a first question. Because question is answer is not difficult to find.
ट्वेंटी थ्री आया था सर इसका।
23
23
sir.
सर आए 23
What?
23 sir.
23 sir.
23, good, thank you. 23. 23 is solution, yes. Even you can do the use the channel remainder theorem and you can compute your solution will be 23. Can you use the method to solve this one, please? Because in exam and anywhere your data may be big. So it is not easy to trace or guess your solution. So that's why you do just practice and use your channel remainder.
सर
Yes, please.
सर नंबर 1 का बोल रहे हैं
Yes.
सर वो तो कर चुके हैं
हो गया क्या?
यस सर आप ही
ये
तो
हुआ?
एग्जांपल बताया था
ये सर एग्जांपल में यही था सर.
ये था क्या? तो रिपीट कर दिया क्या मैंने? 232. I think this first one होगा. Oh, sorry, this is first one. Sorry. I have to remove this one from here. Yes, thank you. I did not cross verify. Now, I think this is not question is answer. This question is answered. Can you try this question? Question number 2. Can you guess the solution of this equation? System equation? Anyone? Can you guess? By trial and error method, what can be the solution? What is the solution of this system of linear congruence equation? Anyone? Because class is a big one. And I think more than
Sir
61.
53.
53.
Yes sir.
53. 53. Okay, you just do that method. We discussed Chinese remainder theorem. I compute this solution using that method. After solving this system of linear congruence, you post your solution on the common WhatsApp group so that I can check your solution. So I got the solution from the Sudarshan. Thank you, Sudarshan. You have solved. So these are the values A1, A2, A3. You have just data collected. N1, N2, N3. Good. Thank you. Then you got the values of capital N1, 16, N2, N3. Good. Thank you. And then you find the values of x1, x2, x3. I think the answer is correct. So finally, just take this sum, consider this sum. This is the first solution. 233 is same as 53 modulo this one. Module 60 system. Thank you, Sudarshan. Your answer is correct. Now we try to solve our next question. This one. 3 and 4, because we have only 4 and 5 minutes. So please try to solve question number 2, 3 and 4. Next, I received solution for Solini. Thank you, Solini. And this is the solution of question number 2. So you have collected the data first, then you compute the use value of small n. This is 60. Then capital N1, capital N2, capital N3. Good. Thank you. Then after that, you compute the values of x1. Good. X2. Good. X3. And then everything you put this in the solution form, and you computed 233. This is same as 23 in module 60 system. Thank you, Swami. Your answer is correct. Now we try question number 3 and 4 also. And next I received solution from Dinesh. Thank you, Dinesh. So same thing I did. Okay, first collecting the data of AIs, small NIs, then compute the values of capital NIs. Good. Then after that, we compute the values of x1, x2, x3. Good. Thank you. And this 233 and then 43. Good. Thank you. Then Artika, thank you, Artika. I received your solution. So this one, 1 minute. Capital M, capital M1, capital M2, capital M3. Good. Thank you. Then x1, x2, x3. Good. Thank you. Then 15, getting as M1, this A1, this one. Good. A1. Good. 3, 20. Good. Thank you. Thank you. Your answer is correct. But maintain noun notation, because I am using the notation capital N1, capital N2, capital N3, and you are using capital M1, capital M2, capital N3. So your answer is not wrong, but please try to maintain same notation, because I have bigger responsibility in this class. We have more than 70 students. So see that in exam, I have to check many copies. I think this is more than 70 copies. Bigger. We each contain more than 20 questions. So in that situation, that in this case, it is very difficult to, if your notation is different from the other notation, it is very difficult to understand. So please try to maintain the same notation. Now, so please try also question number 3 and 4. Now, I have solved one question also here. I'll just leave this one. Problem 5.1/3. And here, what is the question? Find the smallest positive integer x satisfying the following system of linear congruence equation. So this is a linear congruence equation. 2x is congruent to 1 modulo 3. This is a 4 linear congruence equation there, and we are going to find the solution of this system of 4 linear congruence equations. Now, but see that this equation and if you want to use the Chinese remainder theorem to solve this system, see the form of Chinese remainder theorem. Here in left side, we have only x. X is congruent to a1 modulo n1. X is congruent to a2 modulo n2. X is congruent to ak minus nk. But in this system, given in the problem 5.1 by 3, the system of linear congruence is this one. 2x is congruent to 1 modulo 3. 3x is congruent to 2 modulo 5. 4x is congruent to 3 modulo 7. And finally, 5x is congruent to 4 modulo 11. This is not same of form we have discussed in the Chinese remainder theorem. So first we make this system of linear equation in the form discussed in the Chinese remainder theorem. So what I did here, can you write, just you multiply, I need some another concept to convert this system of linear congruence equations in the form of discussing Chinese remainder theorem. So for that, we have a somewhere but forget to discuss in the last lecture. Yes, so come to the here, whatever discuss that. First you consider your just recall, see that to consider this linear congruence equation, x is congruent to b modulo n, and we have discussed that in some cases some linear congruence don't have solution, some equation has solution, in which case this system this equation has a solution, in which case don't have solution. So this or that this theorem is important, theorem 4.0.9, and this theorem say that if d is GCD of a and n sorry, your equation is x equal to congruent to b modulo n, and where d is nothing but GCD of a and n, and this equation has a solution if d divides b, and if d does not divide b, then we don't have a solution. And the number of inequivalent solution is nothing but d, and just we write all d inequivalent solution that has formed this form and c, and if d is equal to 1, that means GCD of a equal to a and n is equal to 1. That means we will get a unique solution of this equation x congruent to b modulo n, because number of inequivalent solution of this equation is nothing but exactly d, and if d is equal to 1, then we will get the unique solution of x is congruent to b modulo n, and that unique solution we call the inverse of a, inverse of a. In this not this in this case. If your equation is x equal to x is congruent to 1 modulo n, then solution of and GCD of a and n equal to 1, then solution I call b, we call the inverse of a modulo n, and we denote by this notation a inverse. So I try to write this one here, like see that not there, 1 minute, I did not write anything here, sorry. One minute, please, 1 minute. Okay, 1 minute here because I did not write any example for that. Sorry for that. So see, suppose I give a equation 11x is congruent to 1 modulo 20. 11x is congruent to 1 modulo 20 because GCD of 11 and 20 is 1 and 1 divides your 1 because your equation is 11x congruent to 1 modulo 20. That means this equation has a solution. And can you tell me the solution of this equation? 11x congruent to 1 modulo 20. Anyone? Your equation is 11x congruent to 1 modulo 20. I am asking for the solution of this equation.
11.
11, good. So 11 is nothing but inverse of itself, 11. That is I'm talking about. Means ऐसा कौन सा नंबर है कि 11 से मल्टीप्लाई करने पे और -1 करने पे वो 20 से डिवाइड हो जाएगा. That is meaning of it. And that number we call the inverse of that 11, which is coming just left in x. So that is this is the concept of inverse. So here, because we have already, our time is now over. Just I'm going to, I need only 1 and 2 minutes, please. So here in this given equation, what I did first, I just, in this first equation, can you tell me the solution of this equation? Anyone? First equation?
2, sir.
2 sir.
2.
कोई क्लास, एक से दो कोई क्लास है क्या?
No, sir.
CS का? ठीक है, हमें 2 मिनट.
No, sir.
ठीक है, 2 मिनट. तो इसका सॉल्यूशन कोई बताए क्या? 2x is congruent to 1 modulo 3. What is the solution?
2 sir.
2. X equals to 2.
2, yes, sir. 2.
One is not working here. So 2 is the solution, and 2 is the inverse of that. Is 2 is the, we call that 2 is the unique solution, and because see that you'll get only one solution, inequivalent solution. With the solution is there 2, and that number 2 we call the inverse of the number 2. Now, then what I did, I just multiply by 2 in this equation. After multiplication, this equation convert into, I'll write here, just I multiply in this equation by inverse of 2. So both sides we multiply, just inverse of 2 each side, so we'll get the 4, because inverse of 2 is equal to 2 into 2, 4, and here in 1 into 1 into 2 modulo 3. So your equation will convert in this form. Now you tell me what is the inverse of this equation? What is the solution of this equation?
4.
4.
For 1 minute. 4. So 3, 2 will not work. 1 is not work. 2 is 6 minus should not work. 3 not work. 4 3 into 4 12 minus 2. Yes, 4 is working. Yes, 4 is the solution, and that solution we call the inverse of 3. That solution we call the inverse of 3 means 3 inverse we denote by 4 modulo something. I write something here, drop something down here. It's actually 4. Sorry, something wrongfully written. Now you tell me the what is solution of this equation?
6.
6.
6.
1. I'm to cross verify. 1 is not working. 2 not working. 3 not working. 3 not working. 4 not working. 5 not working. 6. Oh, 6 is working. Yes, good. Thank you. So 6 is the solution of this one. So 6 is solution. That means 6 is solution. And here, what is the solution of this one?
3.
3.
Confirm.
Yes, sir.
Yes.
Yes,
3
sir.
is solution.
Yes, sir. Yes, sir.
What I did, just I multiply inverse of 2 in this first equation, inverse of 3 in second equation, inverse of 4 in third equation, inverse of 5 in the fourth equation. मल्टीप्लाई करने के बाद ये सब टर्म हट जाएगा, 2 अपने इनवर्स से गायब हो जाएगा, 3 अपने इनवर्स से गायब होगा, 4 अपने इनवर्स से गायब होते हैं, और 5 अपने इनवर्स से गायब, यानी कि लेफ्ट साइड में x बचेगा और राइट साइड में व्हाट एवर इनवर्स, दैट मींस राइट साइड विल गेट द, just to multiply 1 with the inverse of 2, so we'll get that x is congruent to, what is the inverse of 2 in this equation? 2. So in here we get the x is congruent to 2 modulo 3. Your first equation will convert in the x is equal to x congruent to 2 modulo 3 when you multiply this equation by inverse of 2. So we'll get x is congruent to 2 modulo 3. Please write down some here, because after what I did, I think this is not correct. I think I have to cross verify. In the next line, you multiply this equation, multiply the inverse of 3. And what is the inverse of 3 we have computed in this equation?
4.
Not 4, I think. 4 is the 4. Sorry, 4 is the solution. So just after multiplying inverse of 3 in this equation, so 4 into 4, just multiply 4 into 3, so 12. 12 is same as, so I think this is correct. So this one, okay. So we'll get the x. X is here inside. What will get here? कुछ गलत हो रहा है लगता है यहाँ पे. यहाँ पे क्या मिलेगा?
The 3.
3 मिलना चाहिए. 3 मिलना चाहिए. Something is wrong here. Because 2 into 3 is, so somewhere we write down, please. I have typed something, but something is mistake from my side. So I have to rewrite this everything here. I will send to you. We write x is congruent to 3 modulo 5. In next line, you get x is congruent to what you get here after multiply with the inverse of 4. Because inverse of 4 is nothing but 6. So 6 into 3 is equal to 18. And 80 is same as in modulo 7 system is
4.
इसके बराबर होता है 4. So we'll get the x is equal to 4 modulo something, and here we'll get x is congruent to what is inverse of 5 in this system? Modulo 11 system में 5 के inverse क्या होने वाला है? Okay, we'll discuss in next lecture. Something.
Sir,
something.
3.
कुछ problem आ रहा है. Sorry. We'll discuss in the next lecture. Sorry. I'm confused. I have to do something calculation, and then we'll discuss in the next lecture. Sorry for that. So we'll discuss everything in whatever is written